This is question 6. In the Caribbean, there's a group of lizards, and the males possess a retractable flap, and that's the one shown in the diagram, termed a dewlap. It's used in courtship, aggressive interactions, and encounters with predators. So they use this it's visible, and they use it to attract mates and scare off predators and things like that. And we've got variation in the colour. On this diagram here, the grey area on the outside, that's the sea. That's the blue sea. And then you've got where it says Haiti, that's the land. And then we've got down the coastline here, we've got various places, and inland as well, where we find these lizards. So the numbers going down, 1, 2, 3, 4, 5, 6, 7, they're all at the seaside, the beach. 8, 9, 10, 11, 12, those are in the land, in the forest. North at the top, central in the middle, south at the bottom. So that's that diagram. And part A is just really describing this data, so the skill of describing this data. And you just need to match up the right lizard to the right pattern. So I'm going to call these by their initials. So Anolis brevirostris, I'm going to call AB, and there's AW and AC just to make it easy. So AB, that's the one that one pattern of orange and white. Well, that's just all white, isn't it? So that's all white. A Websteri, AW, where's that? That one's the one at the top. That's all orange. So they're just testing whether you can look at this diagram and get the information. So this is AO2. And AC, that's part white, part orange. Yeah, but it seems to be varying amounts, but there's always both colours there. So part white, part orange. Describe how the 3 species are distributed between the 3 zones. So here's our north, central and south. It gives you the site numbers. So in the north, sites 1 and 2 and 3, which one of our lizards have we got? So in the north, that's a Websteri. So north, that is a Websteri. Then we've got central, and then we'll have south. So in the central, that's our A cordalis, AC. And in the south, that's our A brevirostris. A brevirostris. So again, it's just seeing whether you can read the data that's available in the picture. Describe how the dewlap coloration varies from north to south in the central zone. So we're just looking at the central zone now. So that is sites 4, 5, 6 and 7. So 4, 5, 6 and 7. How the colour variation, so it varies from north to south. So from 4, what have we got? We've got tiny bit of orange, lots of white. Then 5, 6, 7. You can see the bit of orange is getting bigger. So that's just what we need to describe. So we can say now almost all white at the north, almost all orange at the south. So just need to describe that. So going from almost all white in the north to almost all orange in the south. Or you might have said it slightly different. So again, that was just AO2. That is describing the data that's available. breeding experiments, and we've got a pair of alleles. So orange is big D, dominant to the white, which is little d. Okay, that's fair enough. And it says one of the gene pools contains no D alleles. We'll use that information later. And here's a Hardy-Weinberg. So with the Hardy-Weinberg, the P, that's going to be, if I write that in just green here, our dominant allele is going to be the big D, and that's associated with P. Our recessive allele is little d, and that's going to be associated with our Q there. And these, in the other equation here, P squared, that is homozygous dominant. The Q squared, that is homozygous recessive, and the ones in the middle, these are our heterozygous. If we put some letters for them, homozygous dominant, that would be big D, the recessive will be little d, and the heterozygous will be big D, little d. So we know what all of these things are in this equation now. What information is it giving us? It's giving us, in the north, we've got 400 lizards, that's our total population, and 4 we found to have white dewlaps. So which ones are these 4 that are white? Well, the information it gives us, that the white is a little d. So these guys are little d, these are our white dewlaps. And so this Q squared, those are our white ones, so Q squared is 4 out of 400. And this is it's a proportion. So 4 out of 400. Where's my calculator? 4 divided by 400 is 0.01. So Q squared is 0.01. We now need to find out what Q is, because the question is asking eventually, if I highlight this in orange, how many of the lizards were, they're orange because they've got the dominant allele there, how many of them are heterozygous? So how many are heterozygous? That's our 2PQ there. So we need to find out what P is. If we're going to do 2PQ, we need to find out what P is, and so we need to find out what Q is. Lost my pen. So if Q squared is 0.01, you can do, well, okay, square root of that is 0.1. So Q equals the square root of Q squared. The square root of 0.01 is 0.1. And if you don't believe me, you can do 0.1 times by 0.1 on calculation, it gives 0.01. Now that we know what Q is, we can go, oh, I know what P is then, because P plus Q equals 1. Well, if Q is 0.1, then P must be, you can do this in your head, 0.9. So P equals 0.9. And now, bingo, we can do these heterozygotes, which is 2PQ. I'm going to switch back to red now. So heterozygotes equals 2 times P times by Q equals 2 times 0.9 times by 0.1. So 2 times by 0.9 times by 0.1 is 0.18. But that is a proportion of 1. So that is like a fraction of 1. But how many lizards do we have? We have 400. So if 400, I can't spell lizards, then heterozygotes is 0.18 times by 400 equals 72. So 72 lizards are heterozygous. Right, last page of this question. And the evolution of these three species is believed to be an example of sympatric. So when you say sympatric, same place. Sympatric, same place. So it's going to be our behavioural kind of speciation rather than geographic. And it says differences in habitats. Explain how the habitat in the south could bring about the dewlap coloration found in A. brev. Right, well, A. brev, what is it? A brev. All white. So these guys are all white. Where do they live? We're using this information. So these are all white and they're living in the forest. The forest is presumably green. So it's saying that they're becoming white, but they're in a green forest. And that ties in with the fact that these, in the stem of the question, it says they use them for aggressive behaviour, mating, courtship, you know, fighting predators and things like that. So you need it to stand out. So that's what we need to say, you know, say how this white colour stands out and how that could come about using our knowledge of kind of natural selection and that sort of thing. So our white dewlaps are more visible. It's very tempting to think, you know, oh, they must be camouflaged if we're talking about colours, but here it's the other way around. They're better if they're whiter. And this is, as ever, if I'm going to talk about natural selection or how things come about, I'm going to talk about you know, it being an advantage or a selective advantage. And it's given us, you know, some reasons, but you know, let's pick one. So these males will attract more females or mate with more females, or you could go along with, you know, they'll scare off more predators. So let's give a reason why it's a selective advantage. So males will attract more females, or we could have will scare off more predators. So that's why it's a selective advantage. What will happen to these alleles? So these alleles will be passed on to the next generation. So more, you know, males will pass on these advantageous alleles to the next generation, and so the frequency of these alleles in the population will increase. So the alleles for white dewlaps will become more frequent, or you could say the allele frequency will increase. So that story there, it's the same whether you're talking about salamanders or, you know, anything at all really. It's the same bit of theory, but this time we're just applying it to our dewlaps. Explain why after many generations the frequency of allele big D is 0 in AB, and little d will never be 0. Right, this is a little bit tricky. Right, big D gives you orange. If we've got orange down here in the south, it's gonna get eaten by predators because you can't scare them off, or it won't be able to mate. Okay. If big D is there, it's dominant, so it's going to be orange if it's big D. Okay, there's no hiding of that allele in the heterozygous because it's dominant. So it'll always be expressed, and if it is expressed, then these guys are a disadvantage. They'll be selected against. So that's why it's going to disappear. The little d up in the north, well, little d for white, well, it might be hiding behind a big D. It might be in the heterozygous, so not expressed. So there's always chance that with heterozygotes, then it'll get passed on because it's not being expressed as white, it's kind of hiding behind the orange. And that's what we need to explain there. So quite a tricky explanation. So in A. brevirostris, I think I'm saying that now, allele D is selected against. It's always expressed, will be removed from the gene pool. But in the other one, in A. websteri, little d will not be expressed in my pen's run out, so I should always have a spare pen, folks. Ta-da! Look at that, seamless. Expressed in heterozygous, so will remain in the gene pool. And the last little bit of this, but it's 3 marks. You've got 4 lines here, 3 marks. A lot of marks for this question. The lizards at site 3 and 4 are different species. Explain how their dewlap colour may have resulted in this speciation. So you need to say 3 sensible things about this speciation. What type of speciation is it? This was our sympatric. So basically we're now, how could this colour possibly be sympatric speciation? And so let's go, well, we're talking about colour, and so if they've got the opposite colour, they're not going to mate, and so there's a reproductive barrier or behavioural isolation. So it's really asking, what do we know about sympatric speciation? That's what this is. It's AO3. We've got to link this situation to our existing knowledge of sympatric speciation. So they have opposite dewlap colours. So one's white, one's orange. Why is this a problem? So males will not attract mates. So it's talked about those courtship rituals. And so there's a reproductive barrier. This is a reproductive barrier. So they do not, interbreed. This is, now I'll write it, behavioural isolation. There we are. Hope you enjoyed that question as much as I did.